Well, f is 0 when y is 0. So that's the x-axis. Okay, so that's the level 0. Where's the level 1? Well, f is 1 when negative y is 1. That means when y is negative 1. So I'll go to minus 1, and that will be where my level 1 is. And so on. F is 2 when y is negative 2. F is negative 1 when y is 1, and so on. Okay? Is that convincing? Do you see how we got that? Okay, let me do it again. I don't see anybody nodding, so that's kind of bad news. So if I want to know where's the level curve, say, 1, I try to set f equal to 1. Let's do this one. F equals 1 means that negative y is 1, means that y is minus 1, and y equals minus 1 is this horizontal line on this chart. Okay. And same with the others. So you can see on this map that the value of a function doesn't depend on x. If you move parallel to the x-axis, nothing happens. If you move in the y direction, it decreases at a constant rate. That's why the contours are evenly spaced. See, how spaced apart they are tells you actually how steep things are. So that corresponds exactly to that picture, except that here we draw x coming to the front and y to the right, so you have to rotate the map by 90 degrees to get to that. It's an unfortunate consequence of the usual way of plotting things in space. Okay, so these horizontal lines here correspond actually to horizontal lines here. Okay. Second example, let's do 1 minus x squared minus y squared. Okay? Or maybe I'll rewrite it as 1 minus x squared plus y squared. It's really the same thing. So x, y. Let's see, where is this function equal to 0? Well, we said f is 0 on the unit circle. Okay, so the 0 level, well, let's say that this is my unit. That's where it's 0. What about f equals 1? Well, that's when x squared plus y squared equals 0. Well, that's only going to be here. So, that's just a single point. What about f equals minus 1? That's when x squared plus y squared equals 2. That's a circle of radius square root of 2, which is about 1.4. So it's somewhere here. Then negative 1. Minus 2, similarly, will be x squared plus y squared equals 3. Square root of 3 is about 1.7. And then minus 3 will be of radius 2, and so on. So what I want to show here is that, so that's minus 3, that's minus 2. What I want to show here is that they're getting closer and closer apart. Okay? So first it's concentric circles that tells us that we have a shape that's a solid of, the graph is going to be a surface of revolution. Things don't change if I rotate. And second, the contour, the level lines, the level curves are getting closer and closer to each other. That means it's getting steeper and steeper because I have to travel a shorter distance if I want my altitude to change by 1. Okay, so this top here is kind of flat, and then it gets steeper and steeper. And that's what we observe on that picture there. Okay? So just to show you a few more, where did I put my... So for x squared plus y squared, the contour plot looks like this. Maybe actually I'll make it. Okay, so it looks exactly the same as this one, but the difference is if you can see the numbers which are not there, so you can see them, then you would know that instead of decreasing as we move out, this one is increasing as we go out. Okay, so that's where we use actually the labels on the level curves that tell us whether things are going up or down. But the contour plot looks exactly the same. For the next one I had, I think, was y squared minus x squared. So the contour plot, well, let me actually zoom out. So the contour plot looks like that. So the level curve corresponding to 0 is actually two diagonal lines. And if you look on the plot, say that you start at the saddle point in the middle, and you try to stay at the same level. So it looks like a mountain pass, right? Well, there's actually 4 directions from that point that you can go staying at the same height. And they actually, on the map, they look exactly like these two crisscrossing lines. Okay, so these are things that go on the side of the two mountains that are to the left and right and stay at the same height as the mountain pass. On the other hand, if you go along the y direction, to the left or to the right, then you go towards positive values. And if you go along the x-axis, then you get towards negative values. Okay. The equation for the function was y squared minus x squared. Okay. So you can try to plot them by hand and confirm that it does look like that. But I trust my computer. And finally, this one, well, so the contour plot looks a bit complicated, but you can see two things. In the middle, you can see these two regions with these concentric circles. Actually, they're not really circles, but these closed curves that are concentric, and they correspond to the two mountains. And then, at some point in the middle, we have a mountain pass, and there we see the two crossing lines again, like on the plot of y squared minus x squared. And so, at this saddle point here, if we go north or south, then we'll go down on either side to the valley. And if we go east or west, then we'll go towards the mountains. We'll go up.